Good afternoon, everyone, and welcome to today's webinar, Staying Ahead of Changing Energy Codes with Fiberglass and Mineral Wool. My name is Stacy Fitzgerald-Redd, and I'm Director of Communications for the North American Insulation Manufacturers Association and the Insulation Institute. NAMA's Insulation Institute is a resource for home builders, insulation contractors, HERS raters, and others in residential buildings to obtain information on the significant benefits of fiberglass and mineral wool insulation in terms of energy efficiency and sustainability. Our focus today is helping builders better understand code changes and meet requirements with fiberglass and mineral wool insulation. In addition, we'll talk about how to create a stronger energy efficiency selling proposition as a builder. Just one housekeeping note before we get started. We'll ask that all webinar participants hold their questions until the end of the presentation. There will be a period at the end of the presentation for you to ask questions, and you simply need to press the button that is the raise your hand signal on the control panel. Without further ado, I'll introduce our speakers, who are Jerry Hackney, Energy Code Program Manager for the South Central Partnership for Energy Efficiency as a Resource, or SPEAR, Cody Wilson, Market Development Manager for Owens Corning, and Lynn Motherow, owner of Austin Design Build. Jerry Hackney brings more than 35 years of experience in construction, repairing, and maintaining structural, mechanical, and electrical systems found in buildings and structures. As Energy Code Program Manager, he advances SPEAR's mission to create a forum for advancing the understanding and adoption of energy efficiency and to implement and support regional projects that promote high energy performance and clean distributed energy in the built environment. Cody Wilson is Market Development Manager for Owens Corning. Cody has been a certified ResNet and California HERS rater for more than 10 years. He's been a certified California and NAHB Green rater for 7 years. He has also had experience in training builders and contractors on California energy codes and Energy Star homes for more than 10 years and is a certified California Energy Code trainer. Our final speaker today is Lynn Motherow, owner of Austin Design Build, a full-service award-winning custom remodeler and design build contractor. Lynn has more than 30 years of experience in residential building and remodeling and has been a member of the Greater Fort Worth Builders Association since 1994 and is also past president of that organization. He has more than 15 years experience as an expert witness in construction defect litigation. Without further ado, I'll turn the program over to Jerry. Jerry?
Thank you very much. Thanks again, everyone, and good afternoon to each of you. Just a quick explanation about South Central Partnership for Energy Efficiency as a Resource, or SPEAR, much easier to remember, and its work. SPEAR is one of 6 regional energy efficiency organizations providing education and outreach, technical support, and other energy-related services. We work with the DOE as well as many of the state and local energy-related organizations. The region we represent is Texas and Oklahoma, which wasn't represented at all until 3 years ago when we were formed for this area. The job of SPEAR is simply to help spread the word and to be a resource to code officials, raters, builders, and the various tradesmen through live presentations, online webinars, such as this one today, and a general resource for energy code information at no cost. Yes, I said no cost. Our mission is to accelerate the adoption of advanced building systems and energy-efficient products and services in South Central U.S. The purpose is to create a forum to advance the understanding and adoption of energy efficiency as a low-cost energy resource to design, implement, coordinate, and support regional projects. SPEAR facilitates an energy code compliance collaborative in each state through an energy code ambassador program, training programs, and person-to-person online interactive trainings and resources for building officials and all building professions in Texas and Oklahoma. These are the logos of most of our members. As you will note that many of them are involved in some aspect of the building and energy industry. Represented are utilities, manufacturers, trade associations, some universities, and nonprofits, all working with the SPEAR staff to promote energy efficiency in our region and beyond. This short presentation today will discuss at a very high level the changes coming in September 2016 under the 2015 IECC as amended by the state of Texas. In the DFW area, most jurisdictions have rightfully, as per the law, adopted the 2009 IECC with some type of amendment, and a few have even moved to the 2012 IECC with amendments. However, a few jurisdictions are under something less than the 2009. These jurisdictions and builders will have a mountain to climb to jump to the requirements of the 2015 code. Suffice it to say that the move to the 2015 IECC will be an eye-opener for many jurisdictions and builders if not ready. So my recommendation, begin your planning now. This bar graph was developed from data provided by Texas A&M University's Energy Systems Lab. It shows that the combined initial cost and the long-term benefits of the state's adoption of energy codes. Specifically, and upon the initial cost of implementing the changes required by a more stringent code, which is on average about $2,000 in each of the state's climate zone, the simple payback for each zone is roughly 2 years, and the total savings to homeowners over 20 years ranges from around $12,000 in Zone 3 and 4 to almost $14,000 in Zone 2. Not bad, huh? Now, these savings would potentially increase with the straight adoption, meaning without any amendments, the insulation requirements such as the 2015 energy codes. However, many times in many jurisdictions and states, these requirements are reduced through ordinances to a code level less than intended, such as a recently adopted Texas Energy Code 2015 IECC with changes to the Energy Rating Index, or ERI, requirements amended and set to begin in September 2016. More about the ERI in just a moment. So back to the chart. It is worth noting that the total cash flow, added monthly mortgage cost, property taxes, and insurance is less than the monthly savings on utility bills. So homeowners could potentially realize an immediate cash flow benefit. This is a great marketing point for builders. As you can see, the effort to drive additional efficiency in homes has reached that 50% goal from the 1980s. This means that code officials, builders, and homeowners realize the benefits of a more energy efficient house. The 2015 IECC, while not measurably different or more stringent than the 2012, but includes some changes or options not previously considered for builders, which we will talk about next. So the 2015 IECC allows 3 separate paths to compliance: prescriptive, performance, and the newest type alternative path, the Energy Rating Index, or ERI. The first 2 paths are similar to previous compliance paths and include additional mandatory requirements, such as blower door testing for air infiltration rates. The ERI path is a blended method that allows the builders to use the 2009 table, specifically 402.1.1 for insulation and fenestration, but they must still meet the mandatory requirements and achieve an ERI or HERS index as required for their specific climate zone. For instance, in Zone 3, it would be a 65 compared to the way it was written nationally of a 51. The state of Texas recently adopted the 15 to begin in September 2016, but amended the ERI from, as I stated, an ERI of 51 to 65. Obviously, local jurisdictions and other states may adopt or modify the national code and the ERI. A few of the mandatory requirements are blower door testing to confirm air infiltration rates, reduce duct leakage requirements, improve window performance, solar heat gain and U factor, wall ceiling insulation levels, 75% efficiency lighting requirements, mechanical ventilation, and R3 insulation on hot water pipes over 3/4 of an inch. Please note that the ERI path, if used, relaxes the requirements for insulation in windows to the 2009 levels. Under the 2009 code, either a visual inspection of the air sealing methods and insulation is allowed, or a blower door test at final to prove compliance. However, under the 2015, and based on the climate zone, the air infiltration rates will be reduced, in this case for zone 3, to 3 air changes. Now, once again, this is climate zone specific. This mandatory requirement may be troublesome for some builders to achieve without an advanced plan to deal with it by working with their rater and their tradesmen. So to highlight the changes, the 2009 code allowed a wider range of results to prove compliance. As you can see, at the rough-in stage with no air handler, there was a allowed leakage of 4 CFM at 25 pascals. If the air handler was in place, it was 6 CFM. Post-construction or at final, you had the choice of to the outside at 8 or total of a 12. The 2015 code is much narrower in range. Note, it says with no air handler 3, with air handler 4, and for post-construction, the total, that's inside or outside leakage, 4 CFM at 25. As to the insulation, and once again, it's climate zone dependent. The requirements for zone 3 are, and if you look at zone 3 across the chart, ceiling was R30, walls 13, and so on. Under the 12 and the 15, particularly the 15, you can see that the ceiling requirements have been raised in R38, and the wood walls are 20 or 13 in the cavity plus 5 continuous on the exterior walls. Texas adopted the ERI amendments notwithstanding. So on this table, a builder would comply with all other requirements, mandatory requirements of the 15, prescriptive or performance, but if they use the ERI path, then they would follow the Zone 3 2009 requirements. So, dealing with high-density products such as fiberglass can help builders meet stringent code requirements like the 2015. And Energy Star and other above code programs in a cost-effective manner. Obviously, the insulation grade is critical, as is the method of training for field crews, which we will address shortly. You will notice on this chart that high density has an R15, and in a 2x6 cavity, it's an R24. This is a very significant improvement for high-density fiberglass. Fiberglass and or mineral wool, along with proper air sealing methods, will produce a low-cost alternative to other forms of insulation. Additionally, fiberglass and mineral wool has high percentage of recycled content and very energy efficient. Provides a dense, effective barrier against heat loss in attics, walls, and hard-to-reach areas. Proper selection and air sealing can also reduce noise in a home, such as between living spaces and mechanical rooms. Air sealing is a critical to the process as any other process when installing a wall system, ceiling system, whatever. When installing particularly fiberglass or mineral insulation. These products are not air barriers, but absolutely are an effective improving material to prevent heat gain or loss through a wall assembly. When air sealing is properly completed, such as with a latex sealant, foam, or road seal, and fiberglass and mineral insulation is utilized, it can and will be effective as spray and foam at a much reduced cost. The photos show the application of an air seal product prior to installing the insulation. Of course, properly aligning the insulation with air barrier is critical for achieving uniform coverage, avoiding gaps, voids, and will reduce conductive air cycles within the wall cavity, which, as you know, reduces the effectiveness of the insulation by allowing heat gain or heat loss, as the case may be. Adds to the discomfort of the homeowner and adds potential moisture issues into the wall cavity. The builder, insulation installer, and the inspector must all understand the thermal boundary. When a cavity in a building assembly has insulation installed in such a way that allows for gaps and voids, heat gain or loss flows through the building envelope, or more specifically, the thermal boundary. Restated another way, more heat will pass through assemblies that have gaps and voids. The more gaps there are, the worse it performs at the lower grade it is given by the rater or inspector. Here's how ResNet, or the Residential Energy Services Network standards, relate missing insulation to grade. The energy rating software models three grades differently. When the rater enters grade 1, software calculates accordingly 100% of the cavity insulation having the R value entered. When the rater enters a grade 2, the software models a cavity as having 98% of their area insulated to the given R value and a 2% uninsulated. At the bottom there, you notice grade 3. 95% of the cavity area is calculated when the given R value, and 5% is treated as uninsulated. As mentioned previously, it is not widely known that fiberglass insulation has up to 50% recycled content, which is always a good thing. These thermal images show in vivid detail the effects of misaligned insulation. The photo on the left is of a knee wall, where the insulation has become dislodged or fallen back from the interior sheetrock, causing air gaps between the wall and the insulation itself, as noted by the dark blue area. The photo on the right is a hip roof configuration where several framing members come together, forming small voids. Even the thickest batt cannot overcome poor contact with the air barrier. Hence the yellow color, which is in this case indicates a very warm attic. Note in this photo the obvious gaps between the two batts, but also note that the stapled flaps of the batt are stapled on the inside of the stud versus the stud face, which is the proper way to complete the insulation. The photo on the right shows the batt facing paper was not installed to the heated side of the wall. This is actually on the garage side. Common mistakes by installers. In this photo, drain lines have been ran to an exterior termination and passed through a number of wall cavities. The insulation installer simply placed the batt behind the pipes instead of properly splitting the batt around the pipes. Obviously, compression of the insulation is not beneficial to the effectiveness of the insulation and reduces the overall wall R value. Always make certain your installer knows what they're doing. Of course, a properly installed system, such as the Bibbs product on the left or the loose batts installed on the right, prove that a great job can be accomplished. I want to thank you for this short presentation, and there's contact information if you wish to know more about SPEAR or if there's any questions that you might have. Would now like to introduce Cody Wilson with Owens Corning. Cody?
Thank you, Jerry. Good afternoon, everybody. Again, my name is Cody Wilson. I am the Market Development Manager for Owens Corning. Owens Corning has hired me to work with builders, contractors, TERS raters on how to achieve the energy codes more effectively, more cost efficiently. I've been doing this now for on and off for over 13 years, working with the energy codes in California and here in Texas. So what you guys are experiencing now going into these codes is very similar to what they've already been doing in California for almost 10 years. So have a pretty good idea how to assist and help you get to where you want to go. And usually when I talk to builders, this first picture kind of explains what most of the builders look like when they see a new energy code coming their way. It's how do we do this? Where do I go? How does this affect my house? How does it affect my bottom line, and how can I absorb those costs and be able to sell it to my customer and also to minimize risk? And that's kind of what we want to explain here with technology of the fiberglass insulation and how the entire system itself works and how can we get you there most cost effectively. This next picture gives you kind of an idea of the overall cost of insulation as a whole of what it would cost for you as a builder. depending on the path that you take to get to the thermal performances of these codes, will determine how these numbers fluctuate. What this kind of gives you an idea is what your kind of guesstimate costs are going to take you to get you to and above code, depending on your climate zone. Depending on the passage you take, determine whether that number jumps up or goes down. So what we want to do is try to show you a path that will help you get there, that number would stay the same, or even in some cases go lower, and show you some examples of why the codes are going towards full performance. When talking about fiberglass insulation, most of the builders that I talk to, they refer to it as old technology. It's itchy. It doesn't work very well. There's much more advanced products out there to achieve what they need to achieve. And kind of what I give an example of a fiberglass insulation is kind of like the involvement of the cell phone. You had your flip phone. At first, you had your Don Johnson phone that was huge and old, and it was big, and nobody ever wanted to use it. Then you went to a flip phone, and then you went to a smartphone. And that's kind of what the advancement of technology of fiberglass insulation has gone throughout the years. It's made with more, like Jerry said earlier, it's made with more recycled content. It's formaldehyde-free. It doesn't itch anymore. So when you're up in that attic and you're blowing in a fiberglass product, you're not getting that itchy feeling. And next to closed cell spray foam, it's the highest R value content you can get in the wall cavity. For an example, you're looking at on this bulletin here, it's showing you an R15 in the 2x4 and an R24 in a 2x6. So if you look at open cell spray foam or cellulose insulation, the most you're going to get into in a 2x4 wall cavity is an R23. And in the 2x4, if you're trying to prevent shavings on spray foam or with cellulose, you're looking at about an R19. So looking at this, you can get a higher R value, and there's also non-intrusive methods to actually measure the R value. What's nice about the product is once it's installed, it doesn't settle. It minimizes moisture because we are in a hot, moist climate, so you have to worry about moisture out here versus in other climates that I've worked with where it's a hot, dry climate. So moisture is not as much of an issue, but here it is. So you don't have to worry about moisture content as well. So, and especially if you're trying to put your ducts into a conditioned area or you're looking at making the houses tighter, as where the codes are pushing you to go towards, you have to worry about making sure you can manage the moisture. What's also nice about the blown-in wall system is that you can achieve a grade 1 install every single time. As you can see, trying to achieve a grade 1, grade 2, grade 3, there's chances of failures. First raters will look at it if you're doing a bad insulation, of chances of being able to fail. By blowing it in, you're achieving the highest R value, and you're also getting a grade 1 install every single time. So fiberglass insulation is not an air barrier. So a combination of creating an air barrier along with our product, with fiberglass products, will give you the ultimate solution to getting to where you want to go. So trying to understand where air is leaking is a key essential piece to trying to make sure that you're hitting the air changes per hour that you're looking for, and to make sure you're getting the most achievable record of what you're trying to do to get to the code or above code. What this graphic kind of tells you is where air leaks the most, and a lot of it depends on where you build. So it's not just taking a blanket approach to air sealing and saying, here, if I just seal everything, that I'm going to get, I'm going to hit to hit the air changes per hour that I want to hit. You can go that approach, but if you figure out how to do it effectively and finding out where air is actually going to leak and where you're going to get the best bang for your buck, will help you achieve where you want to go as far as getting houses as airtight. For an example, we've done some houses that were in all spray foam communities. Houses were testing at around 2.5 air changes per hour. We went in and did some advanced sealing techniques and showed the framers, the architects, and worked with them on how to air seal properly and how to frame properly, and we were able to get houses that down to 1.5 air changes per hour, same exact floor plan here in Texas. So there is effective ways to do this more cost effectively. These are some examples that we wanted to show you of some different examples how to effectively do air sealing. The picture on the top left-hand side is a picture of the blow-in wall system, and on top of that is a product that's similar to seal that you would put at the bottom plate. And what we did is we put it at the very top plate, so when that drywall hits that top plate, you created a seal of unwanted air coming in from the attic into the living area. Just by doing that alone can help you change your air changes per hour and lower it to almost 1 air change per hour. The problem is that there's not many products that can actually go at the top plate without having to worry about the drywallers actually scraping it off or lifting it up. So there are some products out there that will help you get there. And if you look at the next picture on the right-hand side, this is something that we've been doing on the exterior top and bottom plate around where the California corners are installed. That's a hard area to try to seal. And so what we're doing is we're approaching it on the exterior of the wall to kind of show you how to try to get that sealed on the outside of the wall before your siding comes in. Also, if you look at the very bottom one, where the register is, that also helps you with your duct leakage. That is a flexible sealant that actually stays flexible for the life of the home. So when you put your drywall up against it, you can also put that at the top plate as well. But that actually helps with your air leakage and making sure that you're sealing the register boot to the drywall. That can make a huge difference on your air leakage test because now your duct requirements are becoming much more tighter. So you have to make sure that those register cans on those register boots are sealed to the drywall and other penetrations that are coming in from after the drywall. The next part that I really want to hit home is you're seeing in climate zone 3 R13 plus 5. And you're trying to figure out how am I going to hit these R values and what's the most effective way of doing it. And there's a reason why the codes are actually drawing you towards going to external continuous insulation on the outside. And one of the main problems and one of the main benefits of doing this is of the continuous insulation requirements is the actual thermal bridging benefits that you're actually getting in a wall cavity. So I've had some builders that would do a 2x4 wall or in a 2x6 wall would flash an inch of closed cell spray foam and then put a bat in it to try to meet the R value. And that is that's an approach to do it. But the problem is that even if you do achieve an R19 or an R20 in a 2x4 wall cavity, if you don't address the thermal bridging benefits, you're losing 22% of the total R value in that wall. So this picture kind of gives you an idea, if you were actually installing an R19, what you're really getting if you took the whole wall assembly and took into consideration the wood that is in between the studs. Whatever you put in between them studs, you still don't address the R value heat loss or heat gain that you get with the stud. So an R19, you're really getting about an R15 in that wall cavity. So you're not getting the full benefit of the actual R value, and you're spending a lot of money trying to get to an R value in between the stud rather than get the R value in between the stud and the R value on the outside of the stud. These next pictures here kind of give you an idea of what we're talking about the heat loss and heat gain in the home. If you look at the picture on the top left-hand side, you will see all the studs just sitting there, losing and gaining heat because wood is not a great thermal performance. So when you put the continuous insulation on the outside, the pictures below it will show you that you can't see the heat loss or the heat gain going into that house because of the continuous insulation. So you're getting a true R value. So for instance, an example, in a 2x4 wall cavity, if you blow in fiberglass in the wall, you'll get an R15. You put an inch of foam board on the outside, you achieved an R20. But you're getting a true R20 rather than trying to achieve an R20 without continuous insulation in between the studs and not putting anything on the outside. You might hit an R20, but really you're only getting about an R15, R16 because you're not addressing the heat loss through the wood. So there's 3 different benefits of using continuous insulation on the outside of the house. 1, we've already talked about, is the thermal performance. 2 is the thermal bridging performance. And then also, it also helps your houses get a lot tighter. It helps with the air changes per hour because you're tightening up the gaps. And also by using tape to tape the seams. So, and depending on what you want to do is you want to ask the right questions when you're putting continuous insulation on the outside and using the proper products. Because if you put thermal performance or continuous insulation on the outside and tape seams, some products will guarantee you a vapor barrier on top of the thermal performance. So the money that you're using for a house wrap, you can use that to offset the cost for using continuous insulation on the outside if you use the proper foam board and tape to tape the exterior of the house. This picture here gives you an idea that you can actually get a tighter home on the thermal performance. If you talk to some of your HERS raters, they will tell you it's hard to get below a 3 air changes per hour without putting continuous insulation on the outside, because it does help with the air changes per hour. Is there other costs associated with using continuous insulation? Yes, you have to look at your pop-outs. You want to make sure you have to pop your windows out. Either you can pop your slab out to make sure that you can make up for that inch. There's different little things that you need to look at, but most builders that I work with continuous insulation, and once they figure out how to do it, it's very, very simple to get there. And once you figure it out, the benefits that go along with this also affect the other aspects of your house. So this is an overall system that we're looking at, not just different stages of the construction site. This is an overall performing wall. And then once you get this piece into the software, kind of like what they talked to you about the ERI or the performance path. It's like getting a bucket and you're putting a line on that bucket, and you got to throw everything in that bucket to get to the line. So what you want to figure out is what's the most cost-effective way to get to that line in that bucket and filling it up. And this is just one approach, because once you do this, then you can take a look at your air conditioning sizing. You can take a look at your window performances, overhangs for shading, and other things that come along to the fact to get you to where you want to go or to that line. Looking at climate zone 3, it's a little bit different than climate zone 2. Climate zone 2, the thermal performances are not as stringent, but if you're in a climate zone 2 and you can get a credit, or you're going to go to an above code to get some type of rebate, this is another performance to help you get there. If you have any other questions or would like to talk to me after the presentation, here is my contact information. Be more than gladly to go over some of the products that we have or some of the different approaches. I work with a lot of the HERS raters throughout the state of Texas. So be more than gladly to work with you and show you some different approaches and some different areas for air sealing, and try to show you how to get to your thermal performances. Next, I'm going to introduce you as a builder who I've worked with in the last year or so, and tried and went through that same exact process that I was kind of explaining to. So he'll explain to you in a little bit more, in a little more detail of where he was and where he went to go, and that's Lynn Motherall. Lynn?
Thank you, Cody. As Cody said, I'm Lynn Motherall, with the owner of Austin Design Build, and I do a lot of work with construction defect litigation. So what I get to do is see the homes when they fail, see the homes when the people are uncomfortable, and just see all the kind of things that happen in homes because of installation issues, et cetera, et cetera. And I've also seen a few homes that we're starting to get involved with that are having some issues with foam insulation, and those have sort of startled me a little bit, and so I've started looking for another alternative. Okay, what we were used to at my company is we were doing open cell in the walls and roof, and we also were getting our R13 in the walls, R21 on roof deck, and we used Tyvek wrap for a vapor barrier. And one of the issues there is with the wraps, they start coming off, and it's really difficult to install them correctly, and I felt like there had to be a better way to do that. I wasn't sure, but then I met a guy named Cody, and he sort of helped me attain that. And so what we're doing now is we're going in the fiberglass, using the continuous insulation on the exterior. And let me say that that's probably the most important thing in my mind, because I got to see in different classes how much loss you were getting through the studs, and it was sort of startling. And once I found out that if I put this continuous insulation all the way around the home, I could eliminate that. It made a huge difference. I also spend a lot of time with my infrared camera checking our projects to make sure that we're not getting any air leaks and things, and it just makes a huge difference, or it's what I've seen on our products once we do this. And the sealing to get our air barrier is very important, and it's really unique because my customers are responding quite well to this, because what I'm trying to do is supply them with the most comfortable home they can get, as well as something that's affordable. And that's sort of key for me is trying to keep the cost reasonable. I mean, we can always do something, but there's always a charge involved with that, and we're not having to pay as much money for that reason. And my customers are telling me that they're extremely happy with their projects, and what my company's doing is we're already exceeding the code by using these technologies that I'm being given. And then with the taping of the insulation, we also are achieving something where we don't have to have our vapor wrap anymore. And that makes a huge difference for me. The project is just better sealed, in my opinion, and I'm getting a great performance for less cost, and I'm also controlling the air quality in the home for my customers and not getting outgassing and things to that effect that sometimes happen with some other products. And if you'll see here, this is one of the latest projects that I completed with the Energy Complete. And what you'll see is in the fourth photograph, we've got a garage that's attached to the living quarters, and we totally sealed that off, and it made a huge difference in the way this home performed. You'll also see in the fifth picture that how we have our continuous barrier on the outside of the living quarters, and then you can also see that it's taped. That's working really well for us, and it's also it's quite easy to install. We also like the fact that we've got the break between the studs and the outside of the wall. As you can see in the sixth picture, you can see how our layers are set up there, where we have the drywall and then the studs, then the insulation, and then the siding. This is key to keeping that thermal break in there and working properly. We it's just an easy product to work with, in my opinion. Okay, now this is what's happening for us on our projects, is we're achieving a higher R value. Also, our AC tonnage has stayed the same, and we also are allowing our air conditioning systems to run properly. They're not cycling and things to that effect, and so that adds tremendously to the comfort of our customers. We're eliminating the moisture risk. A long time ago, when we started tightening our homes on our own, we started having issues that I noticed when I was getting called out to projects where builders were having problems with moisture. Is there was water on the windows, to where with the people in there generating the BTUs, the moisture and stuff, we started seeing that there were issues with air quality, and we started getting a little mold that came out of some of the air conditioning vents and all, and that's one of the things that got my attention and had me looking for a better way to take care of my customers, and I feel that's what we're doing. And we have definitely lower duct leakage, and that's key for the project. By installing the continuous exterior insulation and taping it, we've eliminated the wrap, as we said before, but that's a great thing for me. Again, I like the way that it performs, and I feel like it's sturdier than just the house wrap. Most of the jobs that I go to look at where there's issues, the house wrap was not applied properly, it's pulled off and it's just hanging in the wall cavity. And I find that the foam, with the foam, we just don't have that issue. And our reduced cost is by about 20%. And this latest project that I did, my homeowners are realizing a little better benefit than that 20%. And we added somewhere around 2,300 square feet onto their home of living space, and they said they've hardly even noticed a change in their electric bill for that reason. That's why I'm doing what I'm doing. And then I've got a new home that we're about to start that we're going to be working on Owens Corning's Comfort Built program to achieve HERS 50. And we're doing a new thing in the attic where we're going to be trying to do we're going to try to set up to where our ductwork is in a conditioned area, and I think that this is going to make a huge performance for our homes, and then we're going to be doing way better than what a spray foam home will do. And then with the ceiling of the home, that gets rid of all of our air leakage and gets our air exchanges down to where we want them. And my customers, when I told them about this, they were just so happy and excited. That's what I'm trying to do and achieve a home that I can afford to sell that doesn't price me out of the market. There's my information. If anyone needs to get a hold of me, please email me at any time, and I'll be glad to answer any questions that you have. Thank you so much.
Thank you, Lynn. Okay. If there are no questions, I thank the presenters and thank the attendees who were on our webinar today. Have a great day.